we will look at the quadrilateral in this video. Now, quad, Q-U-A-D, it means 4, stands for 4. So this is a polygon that has 4 sides and of course 4 angles. Now, let me draw an example of a quadrilateral here. I have my 4 sides, 1, 2, 3, 4, and 4 angles, 1, 2, 3, 4 angles here. Now, what is the sum of all these angles? Let us figure that out. We have these 2 lines here. These are 2 diagonals, right? Dia means across. So for example, diameter, it means across a circle, or your diaphragm is that tissue that goes across your chest. Dia means across, so we're going from one corner to the next across the quadrilateral, and we have 2 of them. But the thing is, we have 2 triangles here. We really divided this into 2 triangles, where we have this triangle and we have this triangle, 2 triangles. So we can divide this into 2 triangles. We could also consider that this is one of the triangles and this is the other triangle that we divide it into, right? Whichever one you want to think of, no problem. Now, if you consider over here as a triangle, and I have my angles, this angle, this angle, and this angle. These are 3 angles of a triangle, and all 3 of them add to 180, right? Then I have over here this angle, and this angle to my other triangle. Now the thing is, when you add them up, right, I have this plus this plus this, that's 180 so far. They add up to 180, plus this angle here, plus this angle here, plus this angle here. All of them gives me 180 degrees. So then, if I add up everything, this angle plus 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 this angle, what I get is this plus this. 180 plus 180 would give me 360 degrees. So whatever the shape of the quadrilateral is, all angles add up to 180 degrees. Alright? So the total angle in a quadrilateral 4-sided figure is 360 degrees. All of them add up to 360. So all 4 angles would add up to 360 degrees, because once it's quadrilateral, we have 4 sides and of course 4 angles. Now we're going to look at 5 main types of quadrilateral. The first type we look at is this square. Let me draw a square here. I want all 4 sides, good. And of course, the 4 angles. Now, this is our square. Now with the square, right, all the sides are of equal length. All the sides are of equal length. The other thing is, all the angles are equal, and I'm drawing them like this because they are right angles. 90 plus 90 is 180, plus 90 is 270, plus the next 90 is 360. They add up to 360 degrees. The other thing is, this side is parallel to this side. I draw one arrow on each to show that they are parallel. This side, 2 arrows, is parallel to this side, 2 arrows. 2 arrows here mean they are parallel. That means the direction is the same. So, it's opposite sides. That means this is the top and this is the bottom. On opposite side of the square. They are parallel to each other. Opposite side here as well, the left and the right, they are parallel to each other. So that is our square. Now let's look at what we call the rectangle. Now with the rectangle, we will have the sides, the opposite sides, right, will be equal in length, but not necessarily, it does not necessarily mean that all sides are equal. Now let me draw an example of a rectangle. Alright, so what we have here is our rectangle. Now, the opposite sides are equal in length. So this at the top and this at the bottom, they are equal in length. This on the left and this on the right, they are equal in length. But the thing now is this. This length at the top is, as you see, I draw it longer than the length at the side. The length at the bottom and top are longer than the length of the left and right sides. So they are different in length. Now, with the rectangle, you have the opposite sides are parallel. Top and bottom are parallel. The left and right, they are parallel. And we have therefore 4 right angles. All angles are equal and they add up to 360 degrees, as is the case with all quadrilateral. Now what this means is that the square is also a rectangle because it satisfies all the conditions. The square is a rectangle because the opposite sides are equal in length and they are parallel and the angles are each 90. The difference now is that the rectangle is not necessarily a square. This is not a square because all the sides must be equal for it to call it a square. So all squares are rectangles, but not all rectangles are squares. We now have what is called a parallelogram. Now let me draw an example of a parallelogram. Okay. So this now is our parallelogram. Alright, now with the parallelogram, the sides which are opposite to each other are equal in length. So you can see this and this are equal in length. So the left and right are equal in length. The top and bottom are also equal in length. The other thing is the angles that are opposite to each other are equal. So what you have in this case is that this angle and this angle are equal to each other. This angle and this angle are equal to each other. Now the diagonals bisect each other. Let's see what that is talking about. If you have a diagonal here and a diagonal here, the length from here to here is equal to the length from here to here. So this diagonal going from upper left to lower, upper right to lower left, cuts the other diagonal in two halves. It bisects that diagonal. The other thing is, this diagonal going from upper left to lower right, it cuts the other diagonal into two halves, this half and this half. So they bisect each other. They cut each other into two halves. The other thing is, the diagonals, they bisect the parallelogram so that you have two congruent triangles formed. So we have a division into two congruent triangles. This triangle and this triangle are the same triangles in length and angles. Also, consider that this triangle here and then this triangle here are two triangles that are exactly the same in length and angles. Now let's look at the square before we move on. The square, it is a parallelogram, right? The two diagonals bisect each other. You have the four angles, this angle and this angle, the opposite angles must be equal. The opposite angles are equal, the opposite angles are equal. And we call these opposite angles because if I should draw a square like this angle will be at the top and this at the bottom, this angle will be on the left and this on the right. It's just that we turn this one so that the bottom is flat. So this angle and this angle are opposite sides and they are equal. This and this are opposite and they are equal. You have opposite sides parallel. So the square is a parallelogram. It is a parallelogram. It's just that the parallelogram, what you call a parallelogram, is not necessarily a square. The rectangle is also a parallelogram. It's just that it's not necessarily a square, right? Now, let's look at what is called the rhombus. The rhombus. Let me draw an example here first. So I have this side. I have this side, this side, this side. Now, this itself is a rhombus. The diagonals, right? First of all, it is a parallelogram. Has to be. the opposite sides must be parallel to each other, right? Now, the diagonals bisect each other at 90 degrees at all times. These two diagonals, they bisect each other, and the angle formed must be at 90 degrees. The other thing is, the angle that is formed and that the diagonals pass through is cut into two halves. This angle, the diagonal cuts it into two halves. This angle, the diagonal cuts it into two halves. Now, this itself is a rhombus. Let me draw another rhombus, a bit exaggerated more than that. Have this itself as a rhombus, a bigger rhombus. Here, the diagonals now, of course, must bisect each other, right, at 90 degrees. Now you can, of course, conclude that all sides must be the same, of the same length, I should say. All sides must be the same length. So the rhombus is like a square that you twist out of shape, right? It's like you have this square and you have storm blow on the side of the square. Heavy breeze blow the side of the square and lean it. The entire square lean because of all of that breeze, right? Now that is the rhombus. So let me write the name of it. Now we have another quadrilateral that is called the trapezium. Now it has four sides, four angles, and so on and so forth. However, only two sides, intentionally you will draw it so that only two sides are parallel, right? It's quadrilateral with only one pair of parallel sides. Only two sides are parallel. You might find a trapezium looking somewhat like this, so that this side, let me do that again. You have, accidentally deleted part of my side down here. So you have this side parallel to this side. You have our third and fourth sides here. So this is a trapezium, right? Trapezium. Here only the top and bottom sides are parallel, but the other two sides are not parallel. I could draw another trapezium like this. Let me draw it properly. This is my other trapezium. Alright? So that this side and this side, the left and right are parallel, but the top and bottom are not parallel. This is another trapezium. So those are the 5 main types of quadrilateral that we will be dealing with, right? At least for this course. Those are the 5 main types of quadrilateral. All of them have 4 sides, 4 angles, because quad means 4, and all the angles add up to 360 degrees. So I will see you in the next video.